Hello students, this is Jayapai speaking. In the last class, I was explaining to you all about a photovoltaic cell, its principle, construction and working. Having studied something about photovoltaic cell in greater detail, we will be moving on today, that is to explain the manufacture of solar grade silicon using ion Union Carbide process. Before going to see what it is all about, I would like to enrich your knowledge on photovoltaic cell. Briefly, I will be discussing about photovoltaic modules, photovoltaic panels and photovoltaic arrays. After knowing what these terminologies are all about, then we will be studying something about advantages and disadvantages of photovoltaic cells. Then we will be discussing at length about Union Carbide process of manufacturing solar grade silicon. To begin with, the photovoltaic modules. Before discussing about that, let me just show you the diagram, because diagram is self-explanatory. And here this one represents a solar cell or photovoltaic cell. One cell produces a very small voltage, say that is about 0.5 volt. Therefore, the voltage that is produced by one cell as such cannot be utilized for any application. Hence, these cells are to be connected either in series or parallel in order to generate high amount of voltage or high power or high current. And therefore, a structure called a module came into existence. So module is nothing but arrangement of solar cells connected in a series or a parallel. Each solar cell produces 0.5 volt and one module is constructed in such a way that one module produces minimum 12 volt. Here all the solar cells you can see they are connected in series. Three lines where series connection is shown, and each line it is parallel to each other. So series or a parallel. So this is nothing but a module. And from modules we can construct panels. Panels are nothing but combination of modules. One or two modules, if they are connected as shown, then panel is formed. From panels, we can develop a complete power generating unit that is called array. So array is a combination of panels as well as modules. So this is all about a solar cell, that is photovoltaic cell, then module which is the combination of cells, and panel which is the combination of one or more modules, and array which is a complete power generating unit consisting of both modules and panels. Now moving on, advantages of PV cells or solar cells. As we have discussed about PV cells working at length, it becomes easy for us to identify some of the advantages. First one, PV cells are eco-friendly energy conversion devices. So they are environmental friendly energy conversion devices. They are not energy storage devices, they are energy conversion devices. They convert energy from the sun, that is light energy from the sun, into electrical energy. And the materials required or used in PV cells, they are very simple and long serving. So what are the materials used in PV cells? Mainly it is silicon, and N-type silicon and P-type silicon. Silicon materials are simple and they are long serving. They do not hence cause less disposal problems. So there is no disposal problems here much. That is because the cells are, cell is a simple construction and materials used here are long serving. Now PV cells as such do not require recharging, as it is an energy conversion device and it converts light energy into electrical energy as long as sunlight falls on it. So PV cells do not require recharging and they produce electrical energy as long as sunlight is available. That is the only condition that PV cells should be supplied with sunlight. Then energy in the sunlight, that is light energy, is getting converted into electrical energy. PV cells generate electrical energy at ambient temperature. That means at room temperature itself, energy conversion is possible in the case of PV cells. And as there are no moving parts in PV cells, most of the PV cell construction you have seen, all the parts there, they are immobile, they are stationary, and hence there is no problem of wear and tear. The raw material used in PV cell construction, that is mainly silicon, and silicon is abundantly available in nature. And these are some of the points which you can list under advantages. Disadvantages of PV cells. PV cells requires energy storage device. That is because PV cells are energy conversion devices. They are not energy storage devices. Therefore, whatever energy that is light energy is converted into electrical energy, that energy needs to be stored. For that, we need one energy storage device, that is nothing but battery. But battery requires maintenance and it needs to be replenished from time to time. The installation cost is high. This PV cell structures or PV cell devices, initial installation cost is very high, but once installed, they can be used for a long time. They generate only DC electricity. So it is not possible to obtain AC here. It is, they generate only direct current electricity. These are some of the advantages and disadvantages of PV cells. Moving on, it is a very important concept we are discussing here, that is all about manufacture of solar grade silicon, that is by Union Carbide process. I am going to make this concept very easy for you as it involves some of the chemical reactions. And as far as your examination point is concerned, this concept is very important. Here you need to understand what are the conversions taking place, what are the various products formed, and how to write the balanced chemical reactions. So main thing you need to understand here, that is what is this solar grade silicon and how it is manufactured by Union Carbide process. Solar grade silicon, its impurity level is comparatively less. So when you compare it with the other grades of silicon, especially metallurgical grade silicon available in nature, which contains a high percentage of impurities, and such grade silicons cannot be used for the manufacture of cannot be used in the manufacture of PV cells. And therefore our aim here is to convert metallurgical grade silicon into solar grade silicon. So our aim is to convert metallurgical grade silicon, which is impure, into solar grade silicon. But how we are converting it? That is not by removing the impurities from the metallurgical grade silicon, but by increasing the impurity concentration, pure silicon concentration in the metallurgical grade silicon. So I want to reiterate, that is we are not trying to reduce the concentration of impurities from in the metallurgical grade silicon. Instead, we are trying to enrich the concentration of pure silicon in metallurgical grade. So when the concentration of pure silicon is increased, automatically there will be reduction in the percentage of impurities in the metallurgical grade silicon, thereby upgrading the metallurgical grade silicon to solar grade silicon. Hope you have understood this, and the method involves mainly thermal decomposition of silane. So method mainly involves thermal decomposition of silane. So silane, it is nothing but SiH4. So silane is nothing but SiH4. It is silicon tetrahydride. It is silane. And when it is subjected to very high temperature, that is pyrolysis, when it is subjected to pyrolysis, that is thermal decomposition, then silicon tetrahydride or silane, it is converted into hyperpure silicon. It is converted into hyperpure silicon when it is heated to very high temperature of the order of 1100 degrees Celsius. Then you get hyperpure silicon, that is 99.999% pure silicon. And this reaction is carried out in a closed chamber. And the hyperpure silicon that is obtained is somehow made to get deposited on a metallurgical grade silicon rod. When this hyperpure silicon is deposited on the metallurgical grade silicon, the purity level of silicon increases, thereby reducing the impurities present in a metallurgical grade silicon. The process by which we are increasing the concentration of pure silicon in the metallurgical grade silicon rod in order to get the solar grade silicon, that is Union Carbide process. Now, the 4 steps involved in the process. The step 1, it is hydrogenation of tetrachlorosilane. So first step is hydrogenation of tetrachlorosilane. So you have to take tetrachlorosilane. This formula very much resembles with that of silane. Silane is SiH4, whereas tetrachlorosilane is SiCl4. So all the hydrogen atoms here are replaced or substituted by chlorine atoms. This is the initial compound we are taking. This is a precursor, we can say, that is tetrachlorosilane. It is now subjected to hydrogenation. Hydrogenation means a reaction with hydrogen in the presence of silicon. In the presence of silicon, you can take a metallurgical grade silicon only. And now when the reaction occurs, you get the first product, that is trichlorosilane. So this compound is a trichlorosilane. If you closely observe, in this there are 4 chlorine atoms, whereas here you have only 3 chlorine atoms, and one of the chlorine atoms is substituted by hydrogen. So there is a decrease in the number of chlorine atoms and corresponding increase in the number of hydrogen atoms. So we have taken tetrachlorosilane in the beginning, and then we have converted it into trichlorosilane. That is the first step, that is hydrogenation of tetrachlorosilane. Now the mixture of trichlorosilane and unreacted tetrachlorosilane you are getting. Mixture of trichlorosilane and unreacted tetrachlorosilane you will get, and these two are to be separated, that is by a process called distillation, because these two are these two differ in their boiling points, and that is why it becomes easy for us to separate them by distillation. And once you separate them, the unreacted tetrachlorosilane, you can recycle it back to hydrogen reactor, because this unreacted tetrachlorosilane, if you are taking back to first step, that is hydrogenation reactor, where this unreacted tetrachlorosilane can be subjected to hydrogenation, you can convert that one also into trichlorosilane. That is the very purpose. And after that, in the step 2, this trichlorosilane, whatever you have got and which you have separated, you have got it separated from tetrachlorosilane, now it is passed into a fixed bed column. Now you are passing it through a fixed bed column, which is filled with a catalyst called quaternary ammonium ion exchange resin, which is filled with the quaternary ammonium ion exchange resin that acts as a catalyst, and this converts that trichlorosilane into dichlorosilane. So trichlorosilane, now there are 3 chlorine atoms, and now this compound dichlorosilane consists of only 2 chlorine atoms, and here hydrogen atom only 1, and here number of hydrogen atom increases by 1. So we have converted tetrachlorosilane to trichlorosilane, trichlorosilane to dichlorosilane. Along with that, tetrachlorosilane is also obtained, and this is taken to step 1 after separation by distillation. These two products are to be separated by distillation, and then this is taken to the hydrogenation reactor to produce trichlorosilane. And this dichlorosilane thus obtained here, it is taken to the third step, where it is passed through second fixed bed column. It is passed through a second fixed bed column that is filled with the quaternary ion exchange resin. Again it is a catalyst, and here this dichlorosilane, it is directly converted into silane. Here we are getting dichlorosilane directly getting converted to silane, and along with that trichlorosilane is obtained. This trichlorosilane, it is taken to step 2, and after separation by distillation. These two are to be separated by distillation, and then this trichlorosilane is taken to step 2, where in step 2 that trichlorosilane is converted into dichlorosilane. Now this silane thus obtained here, now it is subjected to thermal decomposition, or it is heated to very high temperature. When it is heated to very high temperature, it undergoes thermal decomposition to give hyperpure silicon. So you get hyperpure silicon, and hydrogen gas is also evolved. This hyperpure silicon is 99.99% pure, that is deposited on a metallurgical grade silicon rod, thereby increasing the concentration of pure silicon in the rod. Indirectly, that is decreasing the concentration of impurities, thus upgrading solar grade silicon rod to metallurgical grade silicon rod to solar grade silicon. Hope I have made the things very clear to you. Here understanding the concept is very, very important. Having understood what it is, you will be able to write it in your own words. And after knowing the concept, what it is all about, you have to write the reactions, practice, because unless and otherwise, the write-up of the reactions is very perfect, I don't think you will get full marks. Therefore practicing is very, very important. So just summarizing, as it is very important, first step, it is our basic purpose or our aim here, it is to convert that is silane. That is silane is nothing but SiH4. It is to be converted into pure silicon. For this process to be taken place, we should have an closed chamber, and the silane is to be subjected to thermal decomposition, to be heated to a very high temperature of the order of 1100 degrees Celsius, that's called pyrolysis process. Then silicon is obtained. This silicon is made to get deposited on the impure silicon rod, that is metallurgical grade silicon rod, thereby increasing the purity level of silicon in the rod, decreasing the concentration of impurities. Here one point to be understood, that we are not removing the impurities from the metallurgical grade silicon. Without removing the impurities, we are trying to reduce its concentration by enriching the concentration of pure silicon in the rod. The process involves the 4 different steps. The step 1 being hydrogenation of tetrachlorosilane. Similar to this silane, we are taking a chloro derivative of silane, that is tetrachlorosilane. Upon hydrogenation in the presence of metallurgical grade silicon, first product obtained is trichlorosilane. This trichlorosilane, along with that you get small amount of unreacted tetrachlorosilane. These two are separated by distillation process, and unreacted tetrachlorosilane is to be recycled or sent back to the hydrogenation reactor. And step 2, the trichlorosilane, it is now passed through a fixed bed column containing a quaternary ammonium ion exchange resin, which is acting as a catalyst. This converts trichlorosilane into dichlorosilane. This is dichlorosilane and tetrachlorosilane. This tetrachlorosilane is taken back to hydrogenation reactor, that is step 1, and this dichlorosilane, after separation from tetrachlorosilane by distillation process, it is taken to third step. In the third step, this dichlorosilane, it is passed through second fixed bed column filled with quaternary ion exchange resin. Here dichlorosilane is getting converted to silane and trichlorosilane. This trichlorosilane, it is separated from silane by distillation, and then it is taken to step 2. Now silane thus obtained, subjected to pyrolysis, thermal decomposition, heated to very high temperature to get hyperpure silicon along with liberation of hydrogen. This hyperpure silicon is deposited on a metallurgical grade silicon, thus converting it into solar grade silicon. Thank you.